All right, so hopefully you're getting acclimated to life in 3 space. We're going to be spending a lot of time working in R3. So we have the coordinate axes. Here's the x-axis, here's the y-axis, and here's the z-axis. And again, you are free to orient these however you want. You could make this the x-axis and you can make this the z-axis. That's fine as long as you label and are clear. However, I encourage you, just to keep from getting seasick, it's really best if we orient the same every time, unless there's a compelling reason to switch orientation. So maybe you're doing a difficult sketch and you need to look at it from a different side. That's perfectly fine. But in general, draw it like this, where that we're looking at the positive x, positive y, positive z. So those are my 3 axes. And as a result, we get 3 coordinate planes. There's lots of planes. For us, a plane is just a flat, infinitely thin slice of space. And we're going to talk a lot about planes. I'm going to hop on Mathematica in just a minute. But let's go ahead and do this by hand first. So the xz plane, here's the x-axis, here's the z-axis. You can, with those 2 axes, you can imagine a 2-dimensional plane that's running right through those. That's the xz plane. Its equation, by the way, if you think about it, is defined by y equals 0. Because look, on the y-axis, here's the y-axis, we're saying if y equals 0 and x and z can be whatever it wants, then you can go anywhere on the x-axis, anywhere on the y-axis, but you're stuck with your x-coordinate equal to 0. You're stuck right there on the x-axis. So you can be anywhere along here, but you can't come out to positive y's or go into negative y's. So that's the xz plane. The xy plane is similar. This is actually, we'll often think about it as the familiar xy plane that you're used to. Here's the x-axis, here's the y-axis, and if you sort of looked down on it from here, then you'd have the same perspective that you used to back in Calc 1 when you were graphing functions of one variable. So there's this flat plane, and then of course there's the y-z coordinate plane as well. And I'll show you on Mathematica in just a minute, but these 3 coordinate planes break up 3 space into 8 octants. So let's switch screens to Mathematica, and then we will graph a little bit, and I'll show you how you can use Mathematica to do these plots. All right, so I've pulled up Mathematica. A couple of things. Mathematica, when it does a 3-dimensional graph, does not automatically include the coordinate axes. And so I've written a little snippet of code here that gives those coordinate axes. And anytime I do a 3D plot, I'll just combine the coordinate axes with the other plot using the show function. And so I'm showing you this because at some point in the semester you will do some Mathematica labs. At least that's the plan. So anyway, here I'm plotting the 3D surface y equals 0. I'm using coordinate plot 3D. You write down whatever your equation is, and then you've got your bounds on your 3 variables. You can see those. And then I went ahead and just chose to make the plane a little bit opaque so we could see through it. And so combining that with my axes, you can see what's going on. This is the y equals 0 plane, which is the same as the xz plane. And so you can see the z-axis and the x-axis, and of course there's the y equals 0 plane. Now we'll talk about this later, but you might wonder, what if I changed it to y equals 1? Well, it just scoots over 1 on the y-axis. It's just a mirror copy of the same xz plane, but it's no longer the xz plane because we shifted it over to y equals 1. So the xz plane is when y is 0. All right, so we could do x equals 0. We're going to get the yz plane. Let me scroll down and we'll try to think in your mind, if I said x equal to 0, what's it going to look like? And boom, there it is. You can spin around and see it, and so on and so forth. Let's do all of them together so I can do multiple plots by putting them in curly brackets. So x equals 0, y equals 0, and z equals 0, double equals on the equals there. And when you do it this way, this allows you to actually see the 8 octants. Now, I'm not going to ask you to number them or know, this is octant 7 or whatever. I don't care. I just want you to know that there's 8. And then we talk about an octant. We're meaning one of these chunks of space. I do want you to know the first octant. The first octant is the octant where x is positive, y is positive, and z is positive. That's this cube. I'm trying to touch the screen, but my fingers aren't showing up. It's this this cube right there. So those are the 3 coordinate planes, and you can see the octants formed as well.